Alright, let's get started. To begin, please go ahead and make a brand new Unit 7 table of contents. Unit 7 is called Exponential and Logarithmic Functions. And then make a brand new warm-ups page on the back. Your very first warm-up is to try to solve for x in the following function: 2 to the x power equals 4. So go ahead and complete your table of contents and this warm-up. Pause the video if you need to, and then move on when you're finished. Alright, thanks for getting that started. Let's go ahead and start with Unit 7.1, which is called Intro to Logarithms. To start talking about logarithms, we're going to need to start by talking about exponential functions. An exponential function doesn't just have an exponent in it, but an exponential function is where the variable is the exponent, or rather the variable is in the exponent. So the x value, or whatever we're trying to solve for, is actually inside the exponent of the equation. An example of this would be y equals b to the x power, where b is the constant base, where constant means it's a number, so b will be a number, and it's the base of the function, so we would say it's b to the power of x, so b is the base being raised to the power. Let's go ahead and take a look at some examples of exponential functions. One basic example of an exponential function could be something like y equals 2 to the x power, where we have a base of 2 being raised to the x power. We could also have more complex examples. For example, y equals -3 to the x plus 1 power. Here you can see our base is still a constant, it's a -3. And the exponent, x plus 1, has the x variable in it. Now, for some of these equations, if we want to figure out what the x value is, we're going to need some way to undo the exponential form. We have to undo the fact that x is being raised as a power. So if we want to solve for x, we need to undo the exponential form. By undoing, I mean we need to find the inverse. So we need to go ahead and look at the inverse of an exponential function. The inverse of an exponential function, the opposite of raising x as a power, is going to be a logarithmic function, which we usually abbreviate as a log function. So the inverse of an exponential function is a logarithmic function, a log function. So let's go ahead and take a look at the function that is a log function. Oh, goodness, that was fun. So y equals log base b of x. That's how that's read out loud. Log base b of x. So b, again, is a base, and it is going to be a constant again. So log base something. The base is going to be a number of x. So let's go ahead and see how logs are tied to exponential functions. And we can see how they're tied together if we figure out how to convert between them. So if we want to convert between a log function and an exponential, let's say we're starting with a log function. We actually convert the log function with something called a log roll. It's a good way to remember how to convert this log function into an exponential. So a log roll says whatever our base is, let's see if we've got room here. We have our base b. We're going to raise it to the power of y. So b to the power of y. That's the bottom half of our roll. And then the top half equals x. So b to the power of y equals x. So we've rolled the values inside the function. We've made a little rolling shape, and we've done b to the power of y equals x, and that is our exponential function. Which means if we have an exponential function, we can convert it back into a logarithm by unrolling it. We're going to go ahead and call that rolling back. If we're going to roll back to our original logarithmic function, We already have our base b right here, so this is actually log base b, just like it was before. The b is always the base. So log base b of x, log base b of x equals y. So again, it makes that rolling motion. Log base b of x equals y. It makes that rolling motion and undoes itself. This is how we can convert between them. So we can do a log roll, b to the power of y equals x, or we can do a roll back, log base b of x equals y. And we're going to be able to go back and forth between these two forms. Now I do want to draw your attention to one thing before we move on. Note, the original exponential function that I showed you was y equals b to the x power. But if you'll notice, our log roll version is x equals b to the y power. And we haven't made a mistake here. There is a very logical reason why these look very similar but are also very different. And it's because the log roll comes from the logarithm, which is the inverse of an exponential. Just like we said, it undoes an exponential function. And an inverse has x and y switched. So one of the things that happened before this log roll was done was that x and y were switched to make it the inverse. So if we see y equals b to the x power, that's an exponential function. But if the x and y have been switched, x equals b to the y power, and the y is upstairs in the exponent, that means that it's a log function and it's the inverse. All right, let's go ahead and take a look at some examples of converting something between exponential form and logarithmic form. So I'm going to have two columns here. We're going to have our first example of the conversion between these two forms, and then we're going to try and fill in some blanks together. So our very first example, in exponential form, we have this function. We have 2 to the 4th power equals 16. So 2 times 2 times 2 times 2 is 16, and that's something that we recognize, and we know that that's true. If we write it in log form, we have to do log base 2 of 16 equals 4, and that's what we have written over here. Log base 2 of 16 equals 4. If we were going to go back from logarithmic form to exponential form, we would have to say 2 to the 4th power equals 16, and that's exactly what we see in exponential form. So we can roll back and forth between these two forms. Let's go ahead and try another example. Let's try example A. Make sure you label this as example A in your notes. We have been given the logarithmic form. Log base 2 of 32 equals 5. So we would want to write this in exponential form. If you'd like, please take a second and see if you can try this on your own. If you need to pause the video, go ahead and do that. All right, let's go ahead and take a look at log base 2 of 32 equals 5. The way that we're going to roll this back into an exponential function, or we're going to do the log roll here, we're going to do the log roll, and we're going to end up with 2 to the 5th power equals 32, which is true. 2 to the 4th power is 16. 2 to the 5th power has been multiplied by 2 one more time. 16 times 2 is 32. So 2 to the 5th power is 32. Let's go ahead and take a look at example B. In example B, we've started with an exponential form, and we want to turn it back into a logarithm. So we're going to have to roll this back to a logarithm. So go ahead and take a second and try it on your own. Pause the video if you need to, and press play when you're ready to go. All right, let's roll this back to a logarithm. So we already have our exponent. 3 to the 4th power is 81. So when we roll it back, we're going to have log base 3 of 81, log base 3 of 81 equals 4. And we've rolled it back. Log base 3 of 81 equals 4. There we go. So we've had some practice rolling back and forth between exponential form and logarithmic form. Let's go ahead and try to do that to find some missing values. So we're going to try and find some missing values using this log roll technique. Our very first example will be example C. Make sure you label it example C in your notes. we have log base 2 of 8 equals x. Go ahead and try to figure out what x is. Pause the video if you need to. All right, if we want to find out what x is, we're going to have to start by raising 2 to the x power equals 8. 2 to the x power equals 8. Now, in order to solve a logarithm, the proper way to do it is to try to get the same base on both sides of your equal sign. So 2 to the x power equals something with another base of 2. So I'm going to try and rewrite the number 8 so that it's 2 being raised to a power. Now, if I wanted to do 2 to a power and get the number 8, I would have to cube it. 2 times 2 times 2. So 2 3 times is the number 8. So if I have 2 to the x power equals 2 to the third power, that means that this x value here must be equal to the number 3. The exponents must be the same if the two sides match. Let's use that technique and try another one. Example D. Log base x of 64 equals 3. Take a second and see if you can roll that into exponential form. All right, if we're going to roll this into exponential form, we're going to have x to the third power equals 64. Again, we're going to have to try to make the two sides match, but I can't make the base x match the base 64. So what I'm going to try to do is make my exponent match instead. So I'm going to try and rewrite my 64 as something cubed. I have to think to myself, what cubed is 64? Now, I should have my first 5 cubes memorized. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. So 4 to the third power is 64. Now, if x cubed equals 4 cubed, that must mean that the x and the 4 are equal. So x equals 4. There we go. All right, let's go ahead and use that logic to try another one. This is going to be example E. Log base 3 of x equals 4. You see what we're doing here? We're putting x in a different spot every time, and we can always use the log roll to try and figure out what that x value is. So go ahead and try to do a log roll and figure out if you can find what this x value is. If we're going to do a log roll for this equation, we're going to have to do 3 to the fourth power equals x. This one's a little easier. All I have to do is 3 to the fourth power, which is 3 times 3, 9, times 3 times 3, another 9, which means that 81 equals x, and we're done. We have one more example here, which is a little bit of a challenge. So let's go ahead and take a look at this and see if we can figure out how to solve it together. So our very last example, example F, says log base 49 of 7 equals x. Let's start this problem by doing a log roll, which means we're going to have 49 to the x power. It's going to equal 7. Now this is a challenge because now the number it's equal to is smaller than the one we started with, but we can use the same technique as our first question to try to solve this one. What I'm going to do is I'm going to try and write my bases as the same number. So instead of a 49 on one side and a 7 on the other, I'm going to try and rewrite this 49 so that I can turn it into a base of 7. Now I know 49 is 7 squared. So 49 is 7 squared. It's also being raised to the x power. So 49 is being raised to the x power. 49 is 7 squared. So I have 7 squared to the x power. And that's going to equal 7. Now I'd like to know the exponent of the 7 on the right-hand side. And it's not being raised to anything, which means it's being raised to an invisible 1. The reason this is so important is because if I do an exponent to an exponent, I multiply those exponents together. That means that my new equation is 7 to the 2 times x power equals 7 to the first power. Now this is going to help me find my solution because once I have the same base, I can just compare those exponents like I did before. If I'm raising 7 to the 2x and it equals 7 to the first power, that must mean that the 2x equals the first power. Now all I have to do is solve for x. I can divide both sides by 2 and x equals 1/2. Now this is a really interesting fact because it is absolutely true. Because we learned in the last unit in 6.4 that the 1/2 power means the first exponent and the second root, which means the 1/2 power really means that what we're doing is taking 49 and raising it to the 1/2 power. That's the same thing as 49 to the first power and the second root. the square root of 49, which does indeed equal 7. So 49 to the 1/2 power does equal 7. There we go. All right. We have a couple more things to talk about. Let's go ahead and take a peek at a common logarithm. A common log is a log with base 10. Now, a base 10 can turn invisible. So you're going to see log base 10 of x written as just log x, because the base 10 can just turn invisible. So if you don't see a base on your logarithm, that's because it's base 10. And when we have base 10, we can actually use our calculators to find solutions to these log problems. The calculator can let you plug in base 10. So let's go ahead and try and use a calculator to solve this guy right here, log of 100. So if you have a calculator, I'd like you to try and plug it in. The log function on our yellow calculators is a button near the top. If I use the calculator on my computer, let's see if I can pull that up here. The calculator on my computer, I would have to hit log of I guess I have to type the 100 first, 100 log, and it tells me the answer is 2. Okay? So it tells me the answer is 2. And that's because we just did the log base 10, and we asked 10 to the power of this number should equal 100. So we just did 10 squared equals 100. And we found the number 2 is the number of the exponent we needed to turn a 10 into the number 100. And that's what the calculator does when you plug in the log button. The very last thing I want to do with you is try to find some inverses. So remember, to find inverses, all we have to do is switch x and y and then solve for y. So switch our input and output and then solve for our output. So let's go ahead and try that with example A of finding inverses. If I want to find an inverse for this problem, 3 to the x power equals y, the very first thing I have to do is switch x and y. So the very first thing I'll do to turn this into an inverse problem, a logarithm problem, is going to be to switch my x and my y. 3 to the y power equals x. Once I've done that, all I have to do is solve for y. I have to get this y by itself, but my y is locked in my exponent. So all I have to do to unwrap it is roll back. I have to turn it back into logarithmic form. So we're going to have log base 3 of x equals y. And now the y is alone. I've switched my x and my y, and this is my inverse function. Let's try one more. In this last example, y equals the log of x plus 2. So my first job is to switch x and y. So this time I'm going to have x equals the log of y plus 2. Now I'm going to have to get this y value alone. It's stuck inside this log, so we're going to have to try to do a log roll to get this y out of my log. Now I don't see a base in this log because it's an invisible base 10. So my log roll is going to have my base 10 to the x power. I have to go backward here, but as long as I do it to the power of whatever's on the other side of my equal sign, I'm good to go. So log base 10 to the the 10 to the x power equals whatever was inside my log. So equals y plus 2. Now the y is no longer inside of a log, it's almost by itself. The very last thing I should do is just subtract 2 from both sides, and I end up with 10 to the x power minus 2 equals y. So I switched my x and y, and then I solved for y, just like we did in the last unit. And that's it. Go ahead and try the homework on Math Excel.